Hello. In this lecture, we'll be going forward where we left from where we left tomorrow. We are going to move forward where from where we left tomorrow. So yesterday we were doing Cauchy's integral theorem, uh, and after doing Cauchy's integral theorem, the time has come to do something called as Cauchy's integral formula. Okay. So what does Cauchy's integral theorem says? So Cauchy integral theorem says that. Okay, just give me a minute. So Cauchy's integral theorem says that if there is a region R where you have a closed curve C, this is your closed curve C in the region R. Okay, and suppose your function is analytic in this region. So fz is analytic within this closed contour C. So fz is analytic in this closed contour C. Then the integration fz dz over this closed contour C would be equal to 0. Okay, and further we also saw that if at all there are residues, okay, and see, so we actually went on to see how would things behave when uh, there are residues. Okay, so I told you about something about residues also, and I told you that uh, how to what is the okay, sorry. So I told you that if there are singularities, let's say if there are singularities in this fashion, so if this is your region R, this is the closed curve in the region R, and if there are certain singularities, okay, and then if you're supposed to integrate your function fz dz, if you have to integrate your function fz dz over this closed contour C, and if you have certain singularities, this will be equals to summation 2 pi iota into residue of function at all those singular points. Okay, so this is what we've been doing till now. अभी तक हम लोग ये कर रहे थे. So we'll move in this direction only, and we'll see a few more things. Like I'll take a lecture separately on what all applications can be there for Cauchy's integral theorem also. But right now we are moving on to something called as Cauchy's integral formula. So we are moving on to something called as Cauchy's integral formula. So what is Cauchy's integral formula? Okay, what is Cauchy's integral formula? Cauchy's integral formula says that if your function fz, if fz is analytic throughout a simply connected region, R, and C is a closed curve. C is a closed curve, you can say, or closed contour, you can say, for that matter. Closed contour in R, then the value of the function, then the value of the function at point z equal to z naught interior to C is given by. So how do you get the value? So value would be equals to fz naught is equals to 1 upon 2 pi iota integral over C fz upon z minus z naught dz. Okay, so it says that if you want to determine the value of a function at an interior point to closed curve C. So let's say if this is your closed curve, and let's say the function is an analytic function, and you want to find the value of function at point, let's say z naught, then the value would be given by this sort of integral. Okay. Okay, so how to go about this thing? So clearly you can see that fz is analytic. But however, if you see, just giving you an idea or motivation, okay, so you can see that FZ is analytic within closed contour C. Within C, which is contained in a simply connected region R. Okay, so this is analytic within C. But what about Fz upon Z minus Z? So Fz upon Z minus Z naught is clearly, if you say that this is your ZZ or something of the different form, is non-analytic at is non-analytic at Z equal to 0. Yes or no? This is clearly understood. So you cannot directly, one cannot directly apply. I will write one cannot directly apply. One cannot directly apply your Cauchy's integral theorem, right? So Cauchy's integral theorem is only applicable for simply connected region. One can not directly apply Cauchy's integral theorem, right? Yes or no? Now, what you have to do, what you can do, you can circumvent this sort of singularity. So you can do what? You can circumvent this sort of singularity, and you can enclose this kind of singularity within a radius of, say, let's say epsilon. Okay, so I'll draw you something. Let's say this is your closed curve C. This is your closed curve C. And let's say this is your point Z equal to Z naught. Okay, so this is your point, let's say Z equal to Z naught. And you enclose this singularity within a circle. I have made it in a very exaggerated sense. Okay. And this Z equal to Z naught is enclosed within a circle of radius, let's say epsilon, and where epsilon would tend to 0 as small as possible, not exactly 0, but as small as possible. Yes or no? Bharat, yahan tak samajh mein aaya? And what you can do, you can clearly see that if I want to integrate over C, again, this is a multiplicated region now. Because see, you have because now you have this kind of thing, now, because your function is analytic in this region. Okay, because I have enclosed the singularity in radius epsilon. So basically, I'm telling my function is analytic in this region. The one that I'm just trying to show you right now, not shading exactly, but otherwise, if you can see on the screen, that this is the region that I'm trying to say that my function is analytic. And this epsilon is as small as possible. So how to make this integration feasible? What I would do, I would create a slit here. So I created a slit of a very narrow dimension, and you know that this is nm and nm, that part we have already done. And this integration would be, so eventually I know, so by previous discussion, we already know what. So let's say this is your curve, I think if I take as some, I think C dash. So by previous discussion, we already know that your integration over C fz upon z minus z naught dz would be equals to what? Integration of fz dz upon z minus z naught over C dash. Is that clear? भरत समझ में आया तो? I think this is clear.
Yes, sir.
ठीक है, ये हम लोग कर चुके हैं, राइट? वापस से इस तरीके से वापस आ जाएगा और एक बार ये इंटर भी करेगा. सो इवेंचुअली ये वाला तो इंटीग्रेशन कैंसिल हो जाता है along m to n then n to m, and eventually you get this kind of thing, that integration over C fz upon z minus z naught dz is equal to integration fz dz upon z minus z naught over C dash. Now over C dash you can clearly see that I would write over C dash you can clearly see any coordinate, any point you can write, any point on C dash would be equals to what? It will be equals to, I think, Z minus Z naught is equals to क्या आ जाएगा? Epsilon e की power iota theta. Yes or no? Because it is centered at, so any point on the circle will be given by Z naught plus epsilon e की power iota theta. What circle? Any point on the circle which is C dash. So any point on the circle C dash would be given by this parameter. Yes or no? Okay, and let us first find what is this. So eventually I would do this C dash fz upon dz upon z minus z naught. I would simply write it as f of z naught plus epsilon e की power iota theta. Then I will again get iota epsilon e की power iota theta d theta. Then you have again divided by epsilon e की power iota theta integration from 0 से लेकर 2 pi. Okay, so epsilon iota theta gets cancelled. This will remain as iota integral 0 to 2 pi, and you have z naught epsilon e की power iota theta and d theta. Okay, and you should understand this I'm doing in the limiting case epsilon tends to 0. And when your epsilon tends to 0, this entire thing will turn towards 0. And originally you are left with only one thing, that is you're only left with I think iota into fz naught. So iota into fz naught d theta is again d theta is again. See, understand my point. Why I can do this? Because at z equal to z naught, your function f is analytic. However, the f z upon z minus z naught was not analytic. But at z equal to z naught, your function fz, I would write here. Why I can do this kind of stuff? You will say, how did you put this limit inside the integration? So you know that fz is analytic at z equal to z naught. And if fz is analytic at z equal to z naught, then fz is continuous. Since fz is continuous, then you can take the limit also. Like your function value nearby and overall would be equal. Are you getting my point? So if your function is a continuous function, then the value of the function at that point is equal to the limit. So basically what you're doing, you're finding limit, and you know that your f is analytic. I'm not saying f is not analytic. I'm saying this is not analytic. F z upon z minus z. But f is analytic. That implies f is continuous. That implies if I take limit, so limiting value would be equal to the value of the function at that point. So I would write this will be iota f z not into 2 pi also. Okay, would be equals to integration over c dash fz upon z minus z naught dz. And further, we know that this particular integration was equal to what? This particular integration was equal to fz upon z minus z naught dz, and I think over c. So you just divide it, so you are getting this answer. So eventually you are left with this thing. So iska matlab, if function is analytic on the closed inside the closed contour C, and if z naught is an interior point to that closed curve C, the function of the value of the function at point z naught is given by 1 upon 2 pi iota integral fz upon z minus z naught dz. Is that clear? This is called as Cauchy's integral formula, not theorem, but Cauchy's integral formula. Is that clear? Bharat, समझ में आ गया?
Yes.
Because today you
हाँ
only
जी
you
सर.
were there. Okay. Maybe we'll move to the
F
problems also, but yes, yes.
Z naught is a singularity, right, sir?
Z naught is a singularity for fz upon z minus z naught. Understand my point, z naught is not a singularity for fz. See, I've already written that in closed curve C, fz is analytic. However, for this particular fz upon z minus z naught is a singularity. So actually I used fz upon z minus z. So I'm trying to prove that fz naught is equal to 1 upon 2 pi iota integral fz upon z minus z naught dz over that closed contour C. Understand that f is analytic everywhere inside. And if it is an analytic everywhere it's inside, at any point I can find the value. So the question is, what is the value of a function at a point z naught? So that value comes out to be equal to 1 upon 2 pi iota integral fz upon z minus z naught dz. Now what I have used is, I've used that fz is analytic, but fz upon z minus z naught cannot be analytic. So what I have to do, I have done from the previous discussion that z naught has to be evacuated. So I have just made a circle here of a radius as small as possible, and I can clearly see that after making a circle of radius, this in this entire region, that is the region which is beyond, which does not include the singularity, fz upon z minus z naught is analytic. Since fz upon z minus z naught is analytic throughout, I can use the Cauchy's integral theorem. So I have used the Cauchy's integral theorem, and I can write that over this c dash would be equals to this. And eventually I found out that this entire thing is equals to iota fz naught into 2 pi. Are you getting my point?
Yes, sir. Sir, fz is a function within the region which doesn't have any singularity, right?
Which does not have a singularity, right?
Okay, sir. Okay.
However, the value of the function fz naught is equal to 1 upon 2 pi iota integration fz upon z minus z. So
Right, sir.
instead of using fz, we have applied Cauchy's integral, the modification of Cauchy's integral theorem by using a slit over this function, that is fz upon z minus z naught. Okay, so what I have done,
Y-
I have done that. I have created a slit kind of pattern, and now I'm saying that in this particular region, if you escaping this slit, not accepting this slit ko bhul jao. In this region I'm talking, in this region you can clearly see that your fz upon z minus z naught. Okay, so fz upon z minus z naught is analytic. There is no problem because we have circumvented the singularity inside a circle of radius of Salin. Okay, so in this region, you can apply Cauchy's integral. So here you can see that your fz upon z minus z naught is completely analytic. There's no problem about it. Since fz upon z minus z naught is analytic, yesterday we told that how to do uh, do how to use the Cauchy's integral theorem for such doubly connected regions, we have to introduce a slit. So we introduced a slit. And by introducing a slit, we know that integration fz upon z minus z naught over c, or integration fz upon z minus z naught over dz over c dash, they mean one and the same thing. But understand, on the c dash, any point can be written in this format: z minus z naught is equal to epsilon e ki power iota theta. And if you go on and proceed further, you'll find that integrations fz upon z minus z naught dz c dash over c dash comes out to be this, that is iota z naught into 2 pi. And what is this? This is eventually equal to this. So you'll find that fz naught is equal to this. What is fz naught? F is analytic inside a circle of radius, inside a curve C in a simply connected region. So it will, since function is analytic, it will be defined for all those points inside that C. So at z equal to z naught, there would be some value. What is that value of that function at that point? It will be equal to 1 upon 2 pi iota integral fz upon z minus z naught dz. This is the formula. Are you getting my
Clear,
point?
sir. Yes, sir.
So this is your formula. This you have to remember. Okay, this is Cauchy's integral formula. Now let us move further and try to find what can be said about derivatives. So what can be said about derivatives? So what can be said about derivatives? If somebody wants to do a question, you can do this question. So try to do this question. If we are talking about a contour mod z equal to pi is described in positive sense, is described in positive sense, that is anti-clockwise, and gz naught is equal to integral 3z square minus 6 divided by z minus z naught dz. Calculate g2. Okay, so if mod z equal to pi is described in the positive sense, and this curve C, you can see this curve C is nothing but mod z equal to pi only. And I'm saying that gz naught is equal to 3z square minus 6 upon z minus z naught dz over this closed contour C, which is given by mod z equal to pi. I'm saying calculate g2. Okay, so how would we do? So right now we have already told, there was a theorem which says that if I want to find the value of a function at a point z naught where my f is analytic, what I have to do is I have to simply write 1 upon 2 pi iota integration fz upon z minus z naught dz. I hope it is clear. So if I just see that, if I just write in this format, if I just write gz naught is equal to 1 upon 2 pi iota integration 2 pi iota outside, and here it is, I think 3z square minus 6 upon z minus z naught dz. So this entire thing would give is actually nothing but gz naught. Okay, are you getting my point?
Sir, why inside 2 pi I?
हाँ बेटा, because I have
Uh,
multiplied and divided by 2 pi iota. So I have divided by 2 pi iota just to keep this structure intact.
sir, we cannot write directly G2 is equal to 1 by 2 pi I integration fz by z minus 2.
And you can do that, but you have to find the value of g. See, for example, what was here? You understand the pattern. See here, uh, the pattern was, you can clearly see that gz naught. Okay, so compare it. Here it is fz naught. Here it was fz. Understand my point? Okay, so if fz naught is here, then inside there was fz. Okay, but understand there was some 1 upon 2 pi at also.
Yes.
So what I'm doing is I'm writing gz naught here. So gz naught is some integration. Then I have to write it in 1 upon 2 pi iota and multiply it with 1 upon 2 pi iota. So this particular structure that I'm marking in red, marking in red, this one, ये क्या होगा? ये gz नहीं हो जाएगा? थोड़ा ध्यान से देखोगे तो. Just compare things. देखो gz naught,
हाँ जी सर, जी सर।
ठीक है, तो gz आपका क्या हो गया? gz comes out to be equal to I think 2 pi iota into 3z square minus 6. अब तुमसे पूछा क्या जा रहा है? Things पूछा जा रहा है what is g2?
G2,
I think
okay sir,
g2 will
to
be
do
equal to 2 pi iota into I think जो भी आ रहा है 12 minus
12
6
pi I.
है ना? So this will be equal to 12 pi iota. Okay, so, such questions may be asked probably, I don't know. This is a simple question, but
Right,
overall, just try to, if you have a familiarity with the structure, even if you don't know the derivation
right,
part, but if you have the familiarity with the structure, then things would do. Now let us move to something called as derivatives of analytic function. I told you on the very first day that in complex analysis, what happens is if in a region R, your f is analytic, then all the derivatives f dash, f double dash, f triple dash exist. That is, I would say that if f is analytic means f dash exist. Now, this theorem can be also said that if your f is analytic, then all your higher order terms are also analytic, because analyticity means what? If I'm saying f dash is analytic, that implies iska derivative exists करे, the double derivative. I'm saying f double dash is analytic, मतलब इसका derivative exists करे, मतलब f triple dash. एक चीज समझो, if in a region R, if I'm saying my function is analytic, if I'm saying that f is analytic in a region R, f is analytic in region R, then f dash, f double dash, f triple dash, f4, f5, dash 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 are all analytic. समझ में आई बात? Are you getting my point? So derivatives of an analytic function, we are doing it just because we have done this kind of thing. So understand my point that how to find derivatives. See, the basic definition for derivatives would remain the same. So eventually, याद करो what I told in the very first class, that if I'm saying my function is differentiable, then f at z naught, then this particular limit should exist and should be path independent. Okay, this particular limit should be existent and should be path independent. Should be finite and should be path independent. Okay, should be unique in that particular sense. Okay, if I'm saying the derivative of function exists at z equal to z. Okay, so now what I do, so let us consider a simply connected region. Let us consider a simply connected region R, and let's say whose boundary is inside there is a closed curve C. So inside there is a closed curve C, and this is, let's say, closed curve C, and let's say this is your point z naught, and here is your point z naught plus h. Okay, so what will be the value of the function at z equal to z naught? That you already know. So value of the function at z equal to z naught you already know. It is equals to 1 upon
2 pi I
2 pi iota integral, I think, over C if I write. So this will be equals to fz. I think I'm not wrong. This will be it. Okay. And what will be the value of the function at z naught plus h? It will be equals to 1 upon 2 pi iota. I think integration, if I'm not wrong, this will be fz. There's no about it. There's no comment about it. So here it will be equals to what? Z minus, instead of z naught, you have z naught plus h. Is that clear? Okay. So if I'm supposed to find the value of the derivative of f at z naught, so what limit I want to evaluate? I want to evaluate this limit, fz naught plus h minus fz naught divided by h. Okay, so this is what I want to evaluate. So this will be equals to 1 upon 2 pi iota integral over C, and this will be equals to, I think, if I just try to minus, so this is 1 upon h, so 1 upon h यहीं पे लिख दो, कोई दिक्कत वाली बात नहीं
z dz
है ना, यहाँ पे ऐसा हो गया, and this will be equals to 1 upon z minus I think z naught plus h हो गया, and then this will be minus 1 upon z minus z naught. एक fz भी आएगा और एक dz भी, right? Is that clear? And if I try to write further, what it will be, I think this will be equals to what? This will be equals to 1 upon 2 pi iota integral, I think, over C. This will be equals to fz, I think, dz. Then there will be something called as, you just have to see this z minus z naught minus h into z minus z naught. अच्छा, ऊपर जाएगा z minus z naught, इधर आएगा z minus z naught minus h, so this will be plus h, I think. Here it will be some plus h gets cancelled with h. Is that clear?
z minus z naught minus
कुछ गलती करी क्या हमने?
h h आ जाएगा. Yes sir, ये सही है.
It is clear. ठीक है. So eventually I'm left with this entire thing. So थोड़ा सा इसको समझते हैं ये हो क्या रहा है. So I will take this term. ये वाला टर्म अपन निकालते हैं. इसको 1 divided by लिख लेते हैं एक जगह, so that things will become easy for you. So एक काम करते हैं. Let us write this particular term. So this is 1 upon z minus z naught minus h into, I think, I should write z minus z naught. अरे काम करते हैं, just वो partial fraction type बना देते हैं, z minus z naught, I think minus h और plus h कर दिया, divided by एक काम करें क्या, इसको कैसे डिनोमिनेटर में लिखेंगे? एक काम करते हैं, z minus z naught minus h, एक चीज हो जाएगी, z minus z naught minus, एक मिनट रुको। ओके, सो देखो अगर इसको सिंप्लीफाई करें तो ये सिंप्लीफाई होगी, क्या आ रहा है देखो, z माइनस जेड नॉट माइनस एच प्लस एच, तो ये तो कैंसिल हो गया, तो देखो माइनस एच प्लस एच कैंसिल हो गया, और z माइनस जेड नॉट से एक ही कैंसिल हो जाएगा, तो इवेंचुअली ये और ये एक बात एक ही होगी ना, दे बोथ मीन वन एंड द सेम थिंग, इजंट इट? either you write this way or either you write this way, one and the same thing.
Yes, sir.
ओके, सो व्हाट इज गुड अबाउट इट, इससे तुम क्या करोगे, यू कैन डिवाइड, मतलब दो दो में डिवीजन हो जाएगा, सो व्हाट इधर यू कैन डू पार्शियल फ्रैक्शंस, इफ यू नो पार्शियल फ्रैक्शन दैट आल्सो यू कैन डू, सो दिस विल बिकम एज 1 upon z minus z naught का होल स्क्वायर, and then there will be I think something h upon z minus z naught minus h into z minus z naught का होल स्क्वायर. Okay, so what you are getting is, थोड़ा सा ध्यान से देखते हैं, तो व्हाट यू आर गेटिंग इज, जो ऊपर वाला इंटीग्रल लिखा हुआ है, दैट इज इंटीग्रेशन जो भी था वो आई एम नॉट, जो भी था यहाँ पर, आई थिंक दिस वाज एफ जेड नॉट माई, मतलब ये वाला एफ जेड नॉट माइनस एफ जेड नॉट अपॉन एच इज इक्वल टू 1/2 पाई आयोटा एफ जेड अपॉन जेड माइनस जेड नॉट इंटू जेड माइनस जेड नॉट, इस 1 को अपन यहाँ पर इस तरीके से लिख देंगे, सो वील प्लेस ऑल दीज थिंग्स हियर, सो वील प्लेस the value here and let us see what happens. Okay, let us see what happens. Oh, sorry. Let us see what happens. Okay. So what happens is this integration that we were evaluating above would turn out to be 1/2 pi iota integration fz dz upon z minus z naught का square upon h upon 2 pi iota integration again over c. I think this is fz dz upon okay, is that clear? Bharat, is that clear?
Yes, sir. Yes, sir.
Okay. Okay. So understand my point. As I say that as limit h tends to 0, so as h tends to 0, this term will become 0. As h tends to 0, this term will become 0 because there is h here.
Yes,
Understand?
H.
So eventually you are left with, because actually what we have to find this in the limiting case, right? H tends to 0. So eventually what you are left with is, I will write here as, so f, I'll write as f dash z naught, because f z naught plus h minus f z naught upon h in the limiting value h tends to 0. This I can write as 1/2 pi iota integration fz upon z minus z naught का whole square dz. Is that clear? ठीक है. Similarly, if I, this is first derivative, so here you have power 2. If you take second derivative, the same thing, like now you apply on f dash z. Now you try to find the derivative of f dash z naught, that is f double dash z naught will be equal to what? It will be equal to f dash z naught plus h minus f dash z naught upon h. So the same steps if you do, you will get something of this sort. So f double dash z naught will get 1/2 pi iota integration. अच्छा कर ही लेते हैं इसको एक बार. So f z, अब एक काम करते हैं यहीं पे कर देते हैं, z minus z naught, I think minus h का whole square minus f z अपॉन z माइनस z नॉट का होल स्क्वायर, राइट, dz, और एक 1/h और है, राइट. f डबल डैश z नॉट ऐसे ही कुछ होगा, देखो f डैश z नॉट प्लस h क्या हो जाएगा, f डैश z नॉट प्लस h क्या है, यहाँ पर बस z नॉट प्लस h लिया, और f डैश z नॉट क्या है, ये अपॉन
Yes,
h.
sir.
ठीक है. सो f डबल डैश z नॉट निकालने की कोशिश करते हैं, तो हाउ टू इवैल्यूएट f डबल डैश z नॉट, सिंपली 1/2 पाई आयोटा, तो यहाँ पे यही रह गया, इंटीग्रेशन fz अपनी जगह रहने दो, h यहाँ आने दो, एंड ट्राई टू फाइंड इट, तो ये हो जाएगा z माइनस z नॉट का होल स्क्वायर माइनस z नॉट माइनस h का होल स्क्वायर डिवाइडेड बाय z माइनस z नॉट का होल स्क्वायर into z minus z naught minus h का square, right? Try to expand it. Try to expand it. So what you will get is f double dash z naught is equal to 1 upon 2 pi iota integration fz upon z, and if you try to expand this is z square with get cancel, इसको ढंग से कर लेते हैं, z square plus z naught का square minus 2z z naught minus z naught का square माइनस z का स्क्वायर आगे क्या आएगा, uh, इसको एक काम करो यार, इसको ऐसा लिखो z माइनस z नॉट प्लस h का स्क्वायर, लाइफ इजी हो जाएगी
सर
then,
टू
ठीक है?
टू
तो
जेड
z
माइनस जेड नॉट माइनस वन।
है ना, तो z नॉट प्लस h का होल स्क्वायर, और यहाँ पे क्या आएगा माइनस 2z इंटू जेड नॉट प्लस h डिवाइडेड बाई सारा जो भी है वो अपन बाद में देख लेंगे, तो z स्क्वायर गेट्स कैंसिल विद z स्क्वायर, ओके?
सर अगर
देयर विल
सेकंड
बी,
वाली टर्म में जेड माइनस जेड नॉट को ए मान ले तो ए माइनस बी का स्क्वायर में पहली वाली टर्म पूरी कैंसिल हो जाएगी।
हाँ राइट, ऐसा भी कर सकते हैं, सॉरी। सो व्हाट यू कैन डू इज व्हाट भरत सेज वो भी सही है, एक अरे यार सॉरी, सो व्हाट यू कैन डू इज, अरे यार एक दिमाग नहीं लगा है, सो इंस्टेड आप एक काम करो, राइट, सो व्हाट यू कैन डू इज, हटाओ इसको, सो व्हाट यू कैन डू इज सिंपली टेक दिस एज वन सिंगल टर्म, लेट अस काउंट दिस एज वन सिंगल टर्म, इसको नहीं एक्सपैंड करते, इसको पढ़े रहने देते हैं ऐसे ही, और यहाँ से क्या करते हैं, लेट अस एक्सपैंड दिस टर्म, ये हो जाएगा z माइनस जेड नॉट का होल स्क्वायर प्लस 2h z माइनस जेड नॉट एंड देन प्लस h स्क्वायर, राइट? ये कहना चाह रहे हो?
यस सर यही करें।
ओके, सो दिस गेट्स कैंसल्ड, एक h स्क्वायर है, टेंस टू जीरो पे देखो h काट के यहाँ पे आएगा, सो देयर विल बी सम, this h remains, so this will be cancelled, ये ध्यान रखो, this h gets cancelled, this h gets cancelled with this, but overall एक z minus z naught remains, एक z minus z naught gets इसको कैंसिल करेगा, तो रिमेनिंग डिनोमिनेटर में यू हैव z minus z naught into z minus z naught minus h का होल स्क्वायर, h tends to zero पे this also tends to zero, so overall you would find that your second derivative is nothing but it is equals to 2 upon 2 pi iota इंटीग्रेशन एफ जेड अपॉन जेड माइनस जेड नॉट का होल क्यूब डी जेड, ओके? सो देखो यहाँ टू ऑब्जर्व करो, यहाँ थ्री ऑब्जर्व करो, यहाँ सेकंड ऑब्जर्व करो, सो अगर इंडक्टिवली आगे बढ़ते जाओगे, सो व्हाट यू विल फाइंड, इंडक्टिवली विल फाइंड इनफैक्ट ये टू फैक्टोरियल है, बिकॉज नाउ एक बार और डिफरेंशिएट करोगे तो यू विल फाइंड दिस काइंड ऑफ पैटर्न व्हिच आई एम राइटिंग, सो nth डेरिवेटिव इज इक्वल्स टू व्हाट, n फैक्टोरियल अपॉन 2 पाई आयोटा इंटीग्रेशन एफ जेड अपॉन z minus z naught की power n plus 1 dz. Is that clear? So this is the formula for the derivative of an analytic function at point z equal to z. What is interesting to see is what was the initial thing that I took. थोड़ा ध्यान से सोचो, what was the initial thing that I took? Initially I only supposed only one thing. क्या initially क्या अपन ने assertion, अपन ने क्या सोचा था, या क्या, where we started it from? We started that fz is analytic at point z equal to z. If you remember, I just started the entire this thing by saying that my function is analytic at point z equal to z naught. That implies my f dash z exists. I tried to find f dash z, and I could end up getting nth derivative. Okay, so in complex analysis, you can see that if your function fz is analytic, then your all the higher order derivatives are defined. See, is that clear? So it is a very powerful statement. I initially also mentioned, again I'm mentioning that if a function f is analytic at a point, its derivatives, that is f dash, f double dash, f triple dash, dash dash dash, are are promised. मतलब पक्की बात है, they would exist, and they are also analytic, and they are also analytic. Analytic means if f dash is analytic, implies f double dash exists, which indeed is the case, and so on and so forth. Is that clear? So these two are very
Yes
powerful theorems. Now we will move on to doing some questions with the residue theorem, and let us do a few more questions. Okay, understood? So where we
यस
left
सर।
it, हाँ बोलो।
सर ऊपर वाले इसमें पता नहीं मेरी कैलकुलेशन में क्यूब नहीं आ रहा नीचे, वो मैंने कहीं कुछ मिस कर दिया। एक बार आप बताएंगे उसे।
वापस देखो z माइनस जेड नॉट का स्क्वायर, यहाँ माइनस करो, और तुमने कहा इसको z माइनस जेड नॉट पे ग्रुप कर दो, तो मैंने क्या किया, z माइनस जेड नॉट का स्क्वायर किया प्लस 2h z माइनस जेड नॉट प्लस h स्क्वायर. दिस इज क्लियर?
यस सर, माइनस एच स्क्वायर आएगा सर वैसे।
आई थिंक दिस ऐसा कुछ, ठीक है. तो दिस गेट्स कैंसिल्ड, और यहाँ पे आएगा आई थिंक माइनस,
माइनस।
ठीक है. सो
यस।
ओवरऑल
यस।
एक एच स्क्वायर बचा रह जाएगा. एक एच यहाँ पर
हाँ
है
जी।
तुम्हारे पास, एक एच से एक एच कैंसिल होगा, सो देयर विल बी सम
यस।
एच अबाउ, वो टेंस टू जीरो को
राइट।
जीरो हो जाएगा, फॉरगेट इट.
राइट।
And this minus minus will become plus 2 and h
प्लस।
gets cancelled. So z minus z naught, this cancel one power here.
यस।
You remain with z minus z naught into z minus z naught minus h का
प्लस
whole
टू
square.
स्क्वायर, ओके सर, ओके ओके, क्लियर क्लियर।
And h can, ठीक है जी. So is that clear?
यस
तो
सर।
देखो तुम, and eventually if you take the third derivative, that is if you apply the very same thing on the second derivative, so you will find that since f dash z is an, you can find f double dash z, f double dash z पता कर लिया. Now apply this theorem on here. So you'll find that एक, if you find that one derivative exists, that is only a single derivative, that is a first order derivative exists, means all the higher order derivatives start existing. The same you cannot apply in real analysis. See, in real analysis, if you have function, let's say x mod x, how would x mod x look like? So fx, this is real analysis I'm talking of real valued function. So here if you have x square x greater than equal to 0 minus x square x less than 0, this is your function. Okay, and this is your function, and if you try to find the derivative, so how would you construct this function? This will be of, I think it is x square, so I'll make x square here and I'll make minus x square here. Okay, so x greater than equal to 0 के लिए x square is this, and x less than 0 के लिए minus x square is this. So जो ये मैंने shade किया है, this is my x mod x. Okay, leave these two flanks. This is your x mod x. You can clearly see that if you try to differentiate, you will get 2x for all x greater than equal to 0 minus 2x for all x less than 0. Okay, and what you can say that this particular f dash x looks like 2 times modulus of x, and you clearly know that your modulus of x is non-differentiable at x equal to 0. Okay, so existence of first order derivative does not imply the existence of second order derivative, because f double dash x would fail at x equal to 0. Are you getting my point? So you know that, so in real analysis, if you have a function whose first order derivative exists, you cannot say all the higher order terms, higher order derivatives are guaranteed. Higher order derivative terms are guaranteed. Okay, but in complex analysis, you have this freedom. If you are saying my function is analytic, all the higher order derivatives are promised or guaranteed. And in fact, you'll find that all these are analytic as well. Are you getting my point? ये चीज समझ में आ रही है?
यस सर, यस।
This is an important theorem in complex analysis. Okay, so we'll take the class in the next class from the residue theorem. So where we left in the very previous session. So these two things I forgot, so I'm telling you. Now I'll take the class from Cauchy's residue theorem. Okay.
ओके सर।
Okay.